Okay, let's try that.
Did you find out? Huh? You pull it? Wow.
Yeah, it will.
Okay. Nice.
It's a short.
Yeah, let's use that series. That's better. Yeah.
And yeah, so we can do that. We can format data labels, and we had said we will select it from this. Instead of that, we will select it now from the short name. That's better. But somewhat better. It's still a little bit of a problem because these points are all cluttered together. Right?
Yeah, correct. Yeah.
So that there are 2 or 3 things we can do. One is we can take individual points. Instead of selecting the entire data series, we can select the data label for an individual point and format it differently, or we can move the data label a little. And then it does a call out.
Oh, I see. Wow. Oh, nice. That's nice. That's nice.
Okay, something like that. It's a little tricky what I've done. Maybe we should do it like this. Right?
Nice. Right.
Now, the other thing we can do in this GV is, and I was thinking, so of course, when we were discussing with Omkar, we had put some horizontal and vertical lines trying to create some quadrants, right?
You should try and draw a line, yeah. What does it mean? Okay, yeah. There are 2 outliers, except for 7 and 6, which are outliers. All the others, there seems to be some kind of correlation between number and revenue. The prices are roughly similar, right? That's what
roughly similar, looks like, no?
Yeah.
Maybe we can just draw a trend line.
You can try and fit for leave out 7 and 6. Can you do that? Can you draw a trend line for me?
Let's try. So first, let's just include everything, and then we'll see how to exclude something. Okay. So let's first now we'll add a chart element, and we can add a trend line. And
looks like if you draw a trend line including 7 and 6, also it will be same as without 7 and 6 because 7 and 6 seem to be on either side of the trend line.
At least it does look like that, no? But let's try. So we'll draw a linear trend line. No, I think it seems like a linear.
Yeah.
Okay.
What do you do for trend line?
So what we did was we add a chart element.
Okay.
And in that you will see there's an option called trend line.
Okay.
And trend line will allow us to do 4 things. We can put a linear trend, we can put an exponential trend, we can put a linear forecast or a moving average.
Okay, linear trend, yeah.
I think linear we will do.
Yeah.
So nice. GS7 does indeed, GS7 and GS6 do fall on either side of the trend line.
It's all right.
GS7 is quite far away from the trend line. Actually, it is really very, very big outlier.
Yeah.
GS6 doesn't appear to be that much of an outlier. GS7, I think GV, the price must be quite high, no? Because the volume is not that much, but the revenue is quite a bit.
It's actually the second largest in terms of volume also. So it's like M01 or something, whatever that mobile phone was in the flip format.
Correct.
So this guy is gears equivalent of M01 is GS7.
Yes. And there is some orange mobile which was GS6 equivalent. No.
There was
the orange mobile was high revenue but low volume. This is high
volume,
low revenue.
Okay, this looks good. Okay, let's show it.
So, one of the things that we can do is to make the y-axis readable. Right now, we are presenting the y-axis in rupees, but we can also present it in lakhs of rupees. Okay. So, what we can do is, if we select this entire legend on the y-axis and we right-click it, we can say format axis. Okay, and we will say display unit currently is none. We want to say 1 lakh.
I see. Okay, it gives you 100,000. Wow.
Okay. So if you say 1 lakh,
it gives you 100,000.
It gives you 100,000. Okay. So now you can see that it is 200 lakhs.
Yeah.
200 lakhs. And how do you know? Because here it is set into 1 lakh. So this is 200 lakh, 400 lakh.
Can you change that into 1,000 to 8 lakhs instead of that?
Really?
Okay. All right. This is good. Let's go show it.
Okay. How the category business has moved over the years.
So let's stop sharing.
Follow the fact that PS4 has gone to 0 and PS6 is jumping from one financial year to the next financial year.
Yeah. Yes, 0.
First will be
GA category.
Okay, so let's once again.
But we want to see year-wise, right? So not month-wise. Year-wise is good. No, month-wise is too much detail. Year-wise.
No, month is too much detail. Let's look at it year-wise, I think.
So we want to see year 20, 19, 20, and
Yeah, so we can take fiscal year as columns. Maybe.
Fiscal year as column. Fiscal year as column and GA category as row.
As row. Yes.
And what will be the cell? The pivot table. What will be the cell? Sum of revenues. Revenues.
What we can do is sum of sales maybe initially.
Sum of what?
Should we do some revenues? We can do either one.
Revenue. Yeah. Okay. Sales. We'll do sales.
Let's do sales. Yeah. Okay. So let me insert a pivot table as usual. So by now I think the student should get used to creating pivot tables like this. The advantage of putting multiple pivot tables on the same sheet, by the way, JV, is that typically the size of the Excel sheet will be smaller because the Excel sheet will then tend to reuse the internal data structures for the pivot tables.
Oh, I see. Such intricacies. Okay.
So what did we say? We said GA category will be rows.
Yeah.
And we said fiscal year will be columns.
Yeah.
And then we wanted revenue as Sum of revenues.
Not sales.
We wanted sales. Okay. So sum of
quantities. Yeah. Volume.
Yeah.
Sales. Yeah. Okay.
Okay. And then maybe the students can then play around to figure out what is the neat graphical way to perhaps represent this. So they can try that, and I think it might also be interesting for the students to see what happens if we look at revenues instead of sales, or if we look at production instead of sales. Okay, so that can be a couple of things that the students play around with.
Yeah. But what is this? What is it saying? It's saying anything or it's not saying anything? It's saying actually BS4 went from 17566 units to 0.
Correct.
BS6 went from 2895 to 61. So that is quite obvious. But
this is going down. BS4 is going down. BS6 is going down.
Decline. So that is the trend. So that is because of COVID. So BS4 is by COVID. You're seeing BS4. You're seeing only the, BS4 has been phased out. So that's what you're saying. BS6 you're seeing ramp up.
Correct.
Yeah.
Correct.
Okay.
Correct. And it's also possible that if there was no COVID, then perhaps BS6 could have been higher.
May have been higher. Yeah.
Right. But hopefully the impact of BS4, BS6 is only COVID.
Yeah. Okay. All right.
Okay. So, like I said, the graphical representation of this, maybe the students can try out. And they might also want to play around with changing this to production or to revenue, some of the other parameters. Okay. So, Shiv, the other thing that we did was we also looked at the revenue in the 2 financial years across gear assemblies. Is this something that is of interest to SGears, or this is not interesting?
It is highly of interest, and I think it answers a question that we talked about earlier, which is which are the products that's giving me the most revenue, right, or most bringing in the money, right, for the company. And so if you see here, the green product gear assembly number 7, it's actually fetched in 2019 to 21, the 2 years together, which is the first 2 columns. It's actually fetched 10 crores, right? That's what it shows. So that's a very strong contribution that's coming from that one product, right? Out of the total sales of 41 crore to a lakhs that you see at the bottom, about a fourth of that revenue, actually, or more than 1/4, right? More than 25% is coming from just one product. So that is the significant insight that you're giving through this analysis, right? With that green. And similarly, the worst contributor or the lowest contributor is actually gear assembly 9, because it's only fetched 1 crore out of 41 crore. So only 2%, 2.5% is coming from that product. Again, partly because of it's a BS6 product, so it did not have revenues in the first year. It only kicked in the second year, right? But you can see that it is overall not contributing that much, right? With all the investment that's gone into BS6, is it really been worth it? Is for this product, right? That's one question that I could see. And then another thing that this kind of analysis is showing is the BS4 products are quickly falling off in 2021, because remember, from April 1st, 2020, no BS6 products could be sold. So the gear assembly 1 and 2 have dropped down to 0 revenue in the second year, right? Which is also coming out nicely in this analysis.
Shiv, your audio is again having a lot of static.
Not sure. Can you hear me?
Yeah.
Yes.
Yeah. So maybe I'll just pick up the final item, right? Which is that the gear assembly 1 and 2, the revenue have fallen off completely in 2021 because they were BS4 products. So this analysis also clearly shows that the BS4 products have actually led to loss of revenue. And so then you can also ask a question: was the revenue of the BS4 products made up by or compensated sufficiently by the revenue from the BS6 products? And that is possibly looking at the 2019-20 revenues and then for the 1 and 2 and comparing it with the 2020-21 for the 9 and 10. And I guess the answer is not fully, right? But to some extent it was compensated.
Right. And I think that's largely because gear assembly 9 doesn't seem to have contributed as much as we expected it would.
Yes, correct. In this particular case, they had to do a redesign of their some of their BS6 vehicles because of some issues discovered subsequently. So this particular there was a delay in the launch of that particular model of vehicle, and that contributed the gear assembly being very low in sales.
Right. Yes, and again, there's a graphical view. I think it summarizes what you just explained to us, Shiv.
Absolutely. Yeah, I think it
Okay.
nicely shows also the impact of COVID, right? In the fact that if you look at 1920, some of the revenues are actually quickly dropping off for 9 and BS6 impact for 9 and 10. It falls to 0. But importantly, it also shows that for gear assembly 9 and 10, right? Although if you look at 1920, they are actually being launched in 2021. But already in 1920, they started to see some uptick in sales.
Right.
And
Right.
how to explain that? Is it because the lead time? Lead time is the
Yes, the lead time that's required to prime the whole manufacturing system, right? So the components have to be produced well ahead of the finished products.
Okay, we'll pause here. Okay, did we want to kick this off?
This one.
yeah. So
This is basically what we have done. Just so that you know, GV, what we've done is we've clustered these gear assemblies into 3 categories: BS4 only, BS6 only, and BS4 and BS6, and plotted against one.
Yeah. So Shiv, I mean, this whole question about BS4, BS6, and so what we have done basically is we have tried to cluster the revenues, because what we saw earlier was the revenue composite revenue picture. Now we are trying to see whether we can see a picture for revenues gear-wise. Not individual gear-wise, but category-wise. So you have put all the BS4 revenues together, BS6 revenues together, and the BS4, BS6, those gears which are gear assemblies that can be used for both 4 and 6 together. So BS4, BS4, 6, and BS6. And of course, the total revenues, all of them put together, those revenues also we have put in one chart. So this 6 together.
The side 4 line completely dries. You can also see the overall pattern that it took us over. It took us. Okay.
Comes out when you look at something is
the most this is possibly a volley lift or the wagon R or the low unit price. So these components need to take higher torque.
Struck me as interesting, Shiv, and wanted your insight into this, is that gear assembly 6 seems to have dropped quite a bit from 1920 to 2021. But gear assembly 7 did not drop similarly, right? So we went from 147K to 73K, 74K for gear assembly 6.
So we saw that revenue, there were some interesting observations on revenue, some interesting observations on quantity. So can we see revenue and quantity together is the next question we asked. And the best way to depict, because there are 2 dimensions, we thought that the best way to depict would be a scatter plot. So Milind, if you can bring up the scatter plot.
Yeah, so Shiv, this is what we did. We plotted the 2-year revenue and the time division. How do you look at this when you look at it from the company's point of view?
They have to look at their entire set of products and figure out which ones we want to focus more on, which product lines we want to grow, and which product lines we want to get out of, right? So if you look at this chart, there's a number of insights that actually come in here. First of all, the first thing that top management wants to look at in these things is what are the most important products for us? And usually most important would translate to a high revenue, right? That being the most significant thing, right? And high profitability. We don't have the profitability dimension here, but you can see that gear assembly 7 is a very important product because it's bringing in the highest revenues of all the 10 products that we have, right? So that is significant. And the fact that the quantity is not very high indicates that it's also a very valuable product, right? Per unit price is quite high for that product. So that is one insight. The other part that we want to look at is what's our, like if you similar to the look at ABC of the raw material, right? You could also think about an ABC of the finished product where you say, are there products that give, that we want to make a lot of quantities, but doesn't really give a lot of revenues. So you can see that gear assembly 6 is kind of like that, where the sales quantity, it's an important product because it is giving decent revenue. It is actually probably the 2nd highest revenue earning, right? If you look at the horizontal or 3rd highest revenue earning product. So it's not unimportant, but it is consuming a lot of effort because we have to make a lot of quantities to reach that revenue. So it is an important product, but maybe not as important as the gear assembly 7. And then you see what we call the products that actually are fetching, they're high in quantity, but low in terms of revenue. So if you see, some of those products like gear assembly 2, and so on fit in that category. And the final one is where we have insignificant quantity, insignificant revenue. So gear assembly number 9 seems to be like that, where the quantity is less, so is the revenue. And we know that the specific reason for this is because a particular automobile model took time to take off. So it is too early to conclude that we should kill the product. But if this was happening year over year, we might kill that product, right? Because why spend efforts on a product that doesn't sell much and doesn't give us a lot of revenue as well. So you could think of this chart as a very insightful chart that helps us to make those portfolio decisions on products, right? And if you look at the kind of line that shows, I would be very interested in the line, in those products that are in the top quadrant, right, where the revenue is high, the quantity is high, or at least the two right quadrants where the revenue is high, right? That would be of most interest to company management typically. But it is a good chart. Another chart that's used very commonly in product portfolio management is by looking at the trend of products over time, right? So what are the products that are new products that are just recently been introduced, but they are growing very fast? What are those products that are stable products that we've had in our portfolio for long, which are kind of our cash cows, right? The new products that are growing very fast and are profitable are the stars. And then you have products which are old, which are declining in revenue, and which are also not profitable, which are kind of the dog products, right? So that's another chart that's very commonly used in portfolio management kind of decisions.
So the cash cow, so you're made into animals, except for stars. You have a cash cow, you have a dog, and you have a star. Okay. And is there anything else? Do you have a pig? You don't have anything else.
I forget the last quadrant, right? There is high growth, high margin products. Then there is high margin, stable products. Then there is low margin, low growth products. And there's one more which I'm forgetting. But yeah, that's a very common analysis that we use for portfolio.
Okay.
So that was good. I think I think we got a good handle of sales trends. Then we saw the thing by gear assembly. So we did some product portfolio type of thing. Now there is also this thing about regions, right? We have some information about regions, regional information. So can we see the regional distribution of revenue? I mean, that is the only thing that is missing. I think if you get some color of the regional distribution of revenues, then I think and there's some question about how many agents should we have and all that. So I guess regional distribution of revenue is important for assigning agents, right? Sales agents. You got to look at the revenue in the region, and according to the revenue, you have to place agents. Either you could divide revenue by something and then put the agent like that. You could decide how many agents in each region, right? So so we need a regional distribution of revenue.
Yes.
So another pivot table, I guess. Pivot table.
So it's a little bit more tricky than that. Okay, so let me share my screen. So now one of the peculiarities is that this data is actually now in a different sheet. This is the data that she has given us. But you can see that
he's given it for 3 months in a different sheet.
He's given it only for 3 months. But more importantly, GV, he has given it to us in a completely different Excel sheet.
Okay.
So now, if we want to look up prices, if we want to look up revenue, etc., we will not be able to look it up in this because that data is in a different sheet.
I see.
Okay.
So, but you have the name.
Now, so the simplest thing to do is
and also this is October 2019, and that is written in something else. Huh? What is it written in that sheet? What is it? It's called something else.
Yes. So the best thing to do, first thing to do, is we should move this data into that sheet. Okay.
How do you
of course, it is possible to look across multiple sheets also, but right now, for the sake of simplicity, we will just copy this sheet into the other sheet that we were working. So how do we do that? We go to this tab and we do a right click. And then we can say move or copy. You can see my screen. You can see the pop-up.
Yeah.
So you say move or copy. And now we'll say we want to create a copy, but we want to create it in the classwork sheet, which is the sheet that we were working in.
Okay.
So we'll call this tab region-wise data. So naming tabs, etc., is actually quite important because it helps you keep track of what you're doing. What we want, my understanding, GV, is we want a table where, let's say, the rows are regions, and the columns are
total.
Right. So October 2019, November 2019, December 2019.
And total.
Now, and the total, yes. And the total. So now we want to know what were the total units sold in the north in October 19. Okay. So first thing is that data is not available to us. Yeah. So we will have to in this case we will have to add a total.
Right. You can't do a pivot because the problem is we can't do a pivot because the October 19 is better off. It's not entry in the column.
Yes.
It's entry of the column. This column. If you type in entry column, if you have a row inside October 19 like that.
Correct.
If you have an entry, yes, same entry, then you put that. But you can't do, okay, this is like what is this is like the result of a pivot table.
Yes, absolutely. Absolutely. So really, there are two options here. One is that we can go back to the ERP and try and get data in some nice form. But this problem is a relatively small problem, so we can just try and quickly do it without getting that. Okay? So now we can see that we have north 16,230 numbers in October, east is 17,135, west is 559.85, and south is 14,308. Now one of the things we can do, GV, is we can copy this.
No, we should look up.
No, in this case, we'll have to copy.
Why can't you look up?
Because what you want here, everything is in columns, and I want to copy this in rows. So here, everything is in one row. Here, I want it in one column.
Oh,
so think of it as transpose of a matrix.
Why don't you write north, east, west, south in the column and
because the format which they want to review it.
That you can write and then you can transpose the matrix. Can't you transpose?
So okay, so I was going to do it at one shot, but you're right, we can do it like that. You're right. So I can do it like this.
Keep it. Okay, fine.
Okay, keep it. So what did we say we will do? We will do east. Sorry.
can just say equal to and point it to
North,
that.
west, south.
Milan,
And then,
you can
no,
just say,
okay, okay,
you can, no, not there. Point it to that. Point it to the north of that previous table.
okay, okay.
Then you
Yeah,
can, that one, yeah.
okay. And now here, I would say this. But now you see, we got this. This is actually a good starting point. But what we have to consider the shift is actually a transform. Okay. Now the good news is that Excel will allow us to do this very easily. Which is we can just cut to this table and we paste.
By pasting your transpose, no? Yeah.
And we say transpose. No, so you have to paste it as values. Paste. So actually, what you have to do is go into paste special. You say I want to paste values, and when you are pasting it, you transpose.
Yeah.
And you got what you want.
Yeah.
Yep. Now, what we need to do is to okay. So first of all, here let's add a total row. Now the next problem, GV, that Archana was trying to solve before that, she wanted to figure out how many sales agents to have, right?
Correct.
And what I remember discussing is that the number of sales agents will depend on the maximum volume that the region sells in a month. So we have to design the number of sales agents for the busiest month in some sense.
Yeah. I thought he said some 5,000 units a person can sell in a month or something.
Correct. But that is in the busiest month, so not in an average month. So we need to find out what is the maximum sale over these last 3 months.
Oh, okay. I see.
Let's figure out what is the max monthly sales.
Okay.
Now, if you want to compute max, actually Excel has a function called max, and it will tell us. So in this particular case, it is 16645, which is what happened in November.
Right. You can't take average because the guy has to be able to handle the max or peak. Okay.
Correct. So if you just like this, then we've got the max monthly sales. And note that it may not necessarily, in this particular case, it all happens to be November. But it could be something else. And just as an example, if I said this was 20,000, then it could take.
Correct.
Now let's go back. Okay, so what did you say? You said the sales per agent is 5,000.
Yeah.
Sorry, no?
Yeah.
Sales per agent, we'll create a cell, and in that cell we just say 5,000. And then we can compute number of agents needed.
Okay.
So what do? We do this, divide it by, and this of course we'll have to, for D14 we'll have to put $.
Yeah.
But you can't really have to put
take feeling of it.
So the way to do that is to say there's a function called round up.
Round up. Okay. Feeling. Okay.
It will give you the next integer. It will give you the integer that is above 3.8.
Okay.
And we want 0 decimal points, 0 just after the decimal point.
Correct.
Okay. So we'll put 0.
You can't have fractional agents.
As an example, if I put 1 here, let's just see what happens. I would have got 3.4.
That's not good.
Okay, but that doesn't need that, right? So we will make this as 0.
We need 4 agents. Yeah.
Okay. So what this tells you is that you need 4 agents in each region, except in West, where you can do it too.
Interesting thing is that if you're done total, just do the max for the total and do the number of agents if you do the total.
Instead of max, you do the total.
No, I'm just saying just take the max of the totals. Just drag that 16,691.
Okay.
I just want to, and drag that 4 thing also down. So you got 13, but 4, 2, 6, 4, 10, 14. You can't have 13 agents. I mean, it looks like you can, if you do the analysis of the total, you got 13 agents, but clearly you can't manage it because how do you distribute this, right? You need, the agent is going to sit in some city, right? It's in Bombay or Pune or whatever. So you got Delhi, Chennai, whatever it is. Regionally, they'll be okay.
Yes.
14 agents. So this, so 13 is, so actually you're going to get 14 because you're sum of the 4, 2, 4, you're 14.
Correct.
So the effective amount of sales per agent.
Actually do this. No, sorry.
You're some there.
Yeah.
Correct. 14, yeah. So if you take 14, if you divide 60, 71 by 14, you get the effective sales per agent.
That is correct. That is one way of looking at it. Yes.
It will not be 5,000, just right? You get something else, you get 4,000.
You can say. Actually, I can do this for each region.
There will be 5,000. Oh, no, it may not be because you're
No,
on.
it's not. It's not. Because I rounded up.
Yeah. You can do it, yeah.
Okay. But the other thing that Archana wanted, GB, is what is the financial outlook, if you remember. That's what she wanted. Right? And what you told us, I think, was that cost of sales agent, she had said was 80,000 rupees, no?
Per month?
20,000 rupees. Yeah.
Per month, okay.
Yeah, and let me. So now, financial outlay.
So the budget, sales budget is required. Sorry,
I can call it sales budget.
Of course, sales budget will include travel and other things, yeah.
So what should I call this?
Sales agent budget, sales agent budget.
Sales agent budget. And this would be number of sales agents into salary per agent.
Yeah.
And again, I have to take this as.
Yeah.
Now, one of the things I wanted to point out, GB, is that when we are using some constant number like salary of the agent or sales per agent, one thing I could have done was, instead of doing it like this, I could have just said G16 into 20,000.
No, that's not a good idea.
That's not a good idea.
Yeah.
So always a good idea to put the constant in a different cell, and then you refer Excel so that you can always change things easily.
Yes.
Right. So this, if you drag it now, we know that we need about 280,000 rupees per month just for sales agents.
Which is reasonable, I think, no? Given that I don't know revenue per month, but it's in crores.
It is in crores.
It might like 1%. It looks like it's like 1%.
What is the revenue per month? We had it here, no? Where did we go? Just here. Yeah, this is. I should have. Well, it's not in crores. In 3 months, it's in crores, but otherwise, it's in about 60 to 80 lakhs.
So 3 lakhs out of 60 lakhs.
It's about 5%.
5%. Oh, it's a lot.
It is a lot, no?
Yeah.
If the revenue goes up to 1 crore, then it's about 3%.
Yeah. the overall sales budget including travel and everything else, they'll have other costs, right? Like channel management. And so the overall cost of 8-7% might be okay.
Yes.
Okay, maybe 5% looks like a lot. Okay, anyway, we'll see what yours is.
Yeah.
Maybe around 5,000. Anyway, it's not 5,000, it looks like 4,000. Maybe we should do it. So 5 should do some 6 or 7 or something.
Okay, let's do 6. Then you don't need 14 agents, you can do 11.
6,000. The effective number might be still only 5,000 actually. When you saw that 5,000, 4,000 something.
Effective volume and the it's going a little above 5.
That's all right. Let it be. This is okay. Of course, East has got 6,000.
So East definitely needs at least one agent more.
I can give one more agent. Give one more agent before that.
I can do that.
Something else is not optimizing.
Correct.
I'm playing around like this. But then now we get 4,400. Too less now. Okay, whatever. Something. Wait. Some weeks like this they can do and figure it out. Yeah.
Correct. Now the other thing is that let's just take a pause. Compute region-wise revenue for 3 months. Region-wise revenue for 3 months. Okay. So GD, all of this that we did was essentially for sales.
Yeah.
Not for revenue. So now let's try and do it for revenue. How do we do that? So for revenue, we will need price.
Yeah.
Price is available in this sheet for us. Now the problem is that we may not, I don't know if the price varies by month. I think price varies by month. Let's look here. We were looking at October.
Unlikely to vary. Even if
No, it is varying by month.
Marginally varying. We just take the average of the 3.
Or we can just look up exactly. See, what I was thinking we can do is we can just look up the price here and do a sum product.
What is? Yeah. Okay.
So
you got sales in this table, and you got the sales in this table. You created this table. This table has the sales.
No. So we have to look at this table because we can't look at this table.
Why not?
Because while there's quantity, this is a mixture of quantities.
But can't I find average price? That's not relevant.
No.
Because average because quantity is.
You will have to weight the average of price.
That's a pain. That's not correct. Okay. I get it. All right. So let's compute that.
So the simplest way to do it is to say let us compute the regional revenue distribution. Okay. So regional revenue distribution. Okay. And then so we will have no.
3 months only. October, November, December.
Correct. What happened?
It's not D1. It's B1. That's the problem. That's much cell.
Yeah.
Okay.
Yes.
And since they're all
the price and the target.
Take a free cell of Excel and do it.
Yeah. The price is not going to change by region. So we should put $1 here. Right? This tells us that gear assembly 1 in October 20. Sorry.
Totally misled. So if you take, I think 1.2 crores, you can take. That looks like 2 crores.
Wrong.
Benchmark becomes seen immediately. Something wrong. Okay, we fix it. Anyway, good. So now what? So
now, whole block we can copy once again for November. So we will do R.
Once we do that, then the rest can be copied.
Yes.
Yeah. Okay.
The same thing now we'll have to repeat. The total sales.
Best nothing actually. Strange, very strange that we're not getting any revenue from this. To your question on breakdown of the revenue by region, northeast, west, and south. You try to compute the total revenue for 19. For that, the slide shape basically responds to your question on. So this slide shape basically responds to your question on breakdown of the revenue by region, northeast, west, and south. You try to compute the total revenue for 19. For that, we have only 1 quarter data, so we have done it for that 1 quarter. And relating, you have given us the data actually, and then we have seen how to compute from there potentially the number of agents. We did a very simple thing, the absence of any rule. We just put a target for each of the agents in terms of sales targets. And then based on that, we computed the number of agents. So that gave us some agents. So it said 4 agents for the north, 4 agents for the east, 2 for the west, and 4 for the south. For some reason, west seems to have lower revenues. You can see that in the next, is that figure also, right? The next. Yeah. So west seems to have, I don't know why west has lower revenues considering that what you mentioned, Pune, Bombay being one of the clusters. So maybe, you can respond to these charts.
Yes.
Yeah.
Yes, absolutely. It's a good analysis where we're looking at regional regional revenues and the focus, right? So we can see that on those 3 months of the quarter, right, definitely it appears like the eastern region is quite high, and so is the northern region. And this depends on the particular mix of customers for this particular company. ACS, they do a lot of business with some of the OEMs that have big manufacturing presence in the east, like Jamshedpur cluster, and also in Uttarakhand in the Pantnagar auto cluster. So that's why you see somewhat higher. And of course, they do have supply to the south. They don't particularly have a strong customer base in the west, although it is an important sector for auto industry. So that's something they have to work on, right? This also shows.
So if you go back to the previous slide, Glenn. So here we have just simply divided the revenue by some number target, and we've got the 4, 2, 4, and 4. But strictly speaking, when you do planning, one would probably think that we should put more agents in west, because that's where you want to increase the sales, right?
Yes. Yes, I think this is probably we could look at a different basis. I think the way that it was worked out by the team was they said, look, we will appoint agents where based on the existing sales quantity to make sure the customer service is improved and all that. And I think for every 4,000 units, they wanted to appoint 1 agent, something like that, right? So that's the distribution.
I think
yeah. The focus of the agent is actually to grow new business, not just take care of existing business. Then we should probably focus more on the west, where there is a good base of manufacturing auto industry, and we don't yet have good enough sales, right? So the sales agents should actually be higher. But this could be like customer service agents who are just taking care of existing business, like making sure that the shipments are reaching on time and logistic issues are worked out, and invoicing is handled properly, and collections are handled properly, those types of things.
So in sales, they use the term hunters and farmers.
Right? Yes, exactly.
So this is more like farming. This is like maintenance of existing customers. Whereas if you want to hunt or you want to open up new customers, then you need to add on top of this some additional agents in the west, specifically for hunting new customers.
Absolutely, very good insight there. And this could be a recommendation to the management.
Yeah.
Okay, we also should wanted your advice. So we did look at this data in 2 different visual representations. A bar chart side by side or a stacked bar chart, and which do you think makes more sense from a management perspective?
I like this one that we're seeing right now, right? The stacked one, because it is simpler for me to visualize. There's not so many bars on the page, and it also gives me the insight into how is it actually broken down by region. So you're using fewer objects in the chart, but still representing the same richness of information. So from a visual representation perspective, our goal is always to convey the most insight with the least crowded chart, right? So I always look at that look very simple, but convey lots and lots of different insights by looking at a very simple, uncluttered kind of representation of the data, right? So I like this one versus the other one, which had I think
this one does seem a little cluttered. No, this does seem a little cluttered.
Exactly.
Yeah.
In fact, if you see the total is also conveyed with the same, so you don't need a separate line, because in this chart, the additive of all the 4 slices is clearly visible. Whereas the top of each bar, I can just see that versus looking for a line, right? So it's very uncluttered.
Right. Yeah. So I think that is an interesting learning. When you're trying to visualize the data, it's important to play around with a couple of formats and try and select a format which is least cluttered but conveys the most information. I think that's a good learning from this slide.
Absolutely. And sometimes what you will find, and what I have found from my experience, is sometimes you get into complex topics. There is so much information to be conveyed, right? And you may sometimes only get one slide to actually convey, because it's a top management presentation. We have only 5 minutes. We can only put in one slide, but you want to convey, like, I don't know, 5 different insights or 6 different insights. That is the science and the art, right? Like, how do you create a chart that is uncluttered? It uses very few structures, right? But yet at the same time manages to convey all of those insights in that one slide. So that's a very important skill that people in the data and analytics field need to pick up. It's a visual representation of information, and how do we excel in that aspect?
So Shiv, on the slide, the one with the percentages, the stack graph with the percentage on the right one, we can see basically that the north region, the percentage contribution has been relatively stable. It's a Pantnagar cluster, whatever you said, right?
Yeah.
Whereas if you see that some things have declared, some things have increased actually, percentage-wise.
Yeah.
Absolute number, I don't know, I'm saying percentage-wise. So if you look, in some sense, it looks like there has been some compensation between east and west. So some reduction has happened in the east, and that has got compensated by an increase in west, or something like that.
Yes, that is true. I think what has happened there is probably some kind of shutdown or labor issue or something in the east, which may have contributed in December to a much lower output there. So you see only 18%. So it went from 71 to 34, right? From a quantity sense, almost half. And in the west actually went up. So probably maybe some winning some additional customers in the west may have happened, and then some issues in the existing customer base may have happened in the east, which results in reduction of orders.
Or they may have prioritized one customer in 1 month and another customer in another month. Does it happen?
Yes, but also remember another thing that's happened during this time is the reduction of BS6, BS4, rather the final leap of BS4. So there was a hump, if you remember, of BS4 components that the East-based, so if they need to sell by March, they need to prompt. These charts can really make us draw the equivalent, what happened in the ways to prompt such discussions, right? So now we come to production scheduling, right? So, so after having seen how much I need to make of gear, a particular gear. In this case, I'm taking the gear 6A, which is the gear that goes into assembly number 6, gear assembly 6, right? And then 6A uses a particular type of blank to convert that blank into the gear called 6A. So now I'm in a very detailed level where I'm talking about just 6A. This is on the factory floor, right? I'm saying I want to make 6A for a particular month, which is October 2019, right? Now, there are two steps, as I said, in making that gear 6A. One is hobbing and the other is broaching. So the hobbing, think of it as cutting the teeth into the blank in the outside, right? The broaching as cutting the things that I need inside, right? The circular thing and that particular joint kind of thing, which is used to join this gear to another gear, the shaft and so on. So those are the two steps. And these are done in what are called workstations. So first I have to do hobbing, take the blank and to make of. Now we come to. So now we come to production scheduling, right? So after having seen how much I need to make of gear, a particular gear, in this case, I'm taking the gear 6A, which is the gear that goes into assembly number 6, gear assembly 6, right? And then 6A uses a particular type of blank to convert that blank into the gear called 6A. So now I'm in a very detailed level where I'm talking about just 6A. This is on the factory floor, right? I'm saying I want to make 6A for a particular month, which is October 2019, right? Now, there are two steps, as I said, in making that gear 6A. One is hobbing and the other is broaching. So the hobbing, think of it as cutting the teeth into the blank in the outside, right? The broaching as cutting the things that I need inside, right? The circular thing and that particular joint kind of thing, which is used to join this gear to another gear, the shaft and so on. So those are the two steps. And these are done in what are called workstations. So first I have to do hobbing, take the blank and hobbing. So I get a gear which is called outside teeth. Then I have to go to the workstation called broaching, where actually I do the internal shaping of that gear. And then I'm done with that gear, right? I've now got gear 6A, which I can then use to assemble with 6B and create the gear 6, which is later down in the production. So I'm only now talking about hobbing and broaching in the two workstations, workstation 1 and workstation 2. Now there's a concept of scrap I want to introduce, right? Scrap means that when you make these gears, you will not always get how much you want to actually make, because some parts will not have the correct shape for some reason. The machine is overheated, or because the particular blank was not a good quality. So when you get to inspection, which is a quality inspection, you might actually have rejects happening. So some parts of the production will actually get rejected. So that's the concept of scrap that shows in the spreadsheet. So when it says standard scrap 2.5%, what we're saying is that I expect that I will only get 97.5% of the loading into the hobbing workstation. So if I start hobbing 100 blanks, I'll only get 97.5, or rather, to make it more easier, if I start 200, I will only get 195 at the end of hobbing, which are good parts. The rest of it's scrapped. The 5 parts are not good to use, so they are scrap, means they're thrown away or sold as scrap and so on. So that's the concept. And then you see what's called the loading. So the loading is really important, and I want to spend a minute on that calendar piece right here. So this is for the hobbing workstation. It's the first workstation that manufacturing process. So here I'm saying, based on my production plan for gear 6A, right, which we saw earlier, for the month of October, if you actually see, I want to make 9,000 units. So that is the actual target. So if you go up to the top of the worksheet again, you'll see that the target is 9,000, but I may not actually get 9,000. So if the target is 9,000, then the detailed scheduler says, this is what I want to make every single day of the month, right, to reach that 9,000 units. And each day, actually speaking, so you see the quantities there. Day 1, I want to make 400. Day 2, I want to make 800, and so on. And there's a reason why you will see that only some weeks have quantities in them. The reason is because I want to make gear 6A on alternate weeks. So you see the week 1, the quantities are there. Week 2, there's 0 quantities, because that machine is now being used to make another gear during that week. Week 3, I come back to making 6A. Week 4, I make some other gear. Week 5, I again come back to making 6A. So this is typically how machines are scheduled. They make multiple products, and they have to change over from one product to another, and they have to be set up to make the new product. So this is the picture for October 2019. This is what I want to make for the hobbing workstation, and the next calendar shows what I want to make in the broaching workstation. Now you see that the quantities for broaching that I plan is already less than the quantities for hobbing. So you see that while I want to do 800 in hobbing, I want to do 780 in broaching. And that's because of the scrap factor I told you about. Like 2.5% of that 800 will get scrapped. I know that that's the average that gets scrapped. So my goal itself is only to do the broaching for 780 because of the 2.5% loss in the process. So this is the monthly amount that I want to make for each of these products.
So this necessarily assumes, Shiv, that hobbing is done before broaching. You can't do it the other way around.
Yes, absolutely. There is a sequence involved. You're very, very right there. So I want to get the hobbing done, then I want to get the broaching done. Now, actually, yeah.
So you have 0 on Monday, right? Presently, you have 0.
Yes.
0 on Monday because you have not got any units from the hobbing workstation.
Yes, absolutely. And this will become very clear in the following table, right? That I'm showing the yellow table below, which shows what's the actual detailed production schedule for 6A in October 2019, right? So you see the first day of the month, there are 2 shifts. I'm operating 2 shifts in my factory. That means morning shift and an evening shift, right? And whenever I start the week, the very first day, the Monday of the week, the first shift in the hobbing workstation, I'm going to do changeover. That means those 8 hours, I'm preparing the particular hobbing workstation to make gear 6A. There are a number of settings that need to be done to make sure it is cutting at the right frequency and all of these things. I need to inspect those settings, record those settings, do some trials and all that. So that takes the entire shift. So that shift, there's no production that's expected in the hobbing workstation. Now it's ready for production. So when it comes to shift 2, the labor comes in, they start doing the hobbing, and they plan to make 400 units in that shift. And then that machine keeps running on 6A for the rest of the week. So you can see that Tuesday, Wednesday, Thursday, Friday, if you go a little to the right, you'll see that the quantity 400 is being planned regularly. But when it comes to Saturday, I want to stop. Right? I do only one shift on Saturday, the 6th of October, and then I have to leave one shift for what's called maintenance. So every time the machine has run for a week, I need one shift of maintenance, which means I need to possibly clean the machine. I need to lubricate the machine, make sure that there's no heating issues. I want to do some some sort of lubrication, whatever. So that shift is dedicated to maintenance. So essentially, in this case study, we only have 6. We have only 6 days, of which 2 shifts are used for one for changeover and one for maintenance. And so I have the remaining 10 shifts in which to actually do the production. So that's what you see in the plan. There's only 10 shifts that are actually planned. Similarly, if you see the next line, you'll see that for the broaching machine, in a very similar way, first on a Monday morning, I do maintenance for one shift, then I do changeover. That means I'm setting up the broaching machine for gear 6A. That takes a whole shift. And on the next day, Tuesday morning, is when I start the broaching operation. And I only plan 97.5%, 390 units, because I know that the 400 that's made in the previous, so the shift 2 of the 1st of October, those 400 I plan, only 390 I know will be actually made. So that then jumps into the next machine, right? That's why you see 390 on the shift 1 of the 2nd October, and so on it goes. And then you see on the Saturday, you'll see that the broaching also stops. And then yeah, exactly. So that's the point.
Okay.
Now this is the way it works. And then if you keep going to the right, you'll see for the next week, this machine is not used. Hobbing and broaching in the plan, they are zeros because I'm now making 6B. So you see after the changeover, gear 6B is starting. And Sundays are holidays, right? That's what it's doing. But the next week, if you see, gear 6B is being made in that particular hobbing and broaching line, and no production of 6A is happening. And then the following week, if you keep going to the right, you'll see again, I will start making 6A. So after the maintenance and changeover, now I have started making 6A, and the following week 6B, and so on. So that's the pattern you'll see throughout this plan, right? So this is the detailed schedule for the machine line for that month, right? So that's what we're seeing here in the plan, right? This is my plan. My action may actually be different, which is the next table. So if you come to the next table, it actually shows actual production. So the first table says, this is my plan, right? I want to make so much in each shift, in each machine. But then you see the actual, you'll see that the number that's actually made is very different from what we anticipate, because in reality, a worker could make a mistake, or there could be a problem in the machine, or there could be some defects in the incoming raw material batch that actually cause more scrap than anticipated, and so on. So in the second table, you'll actually see that the actual quantities that are being made from hobbing and broaching are very different. So I plan to make 400, but I actually only made 388. Similarly, the next shift I plan to make 400, I actually hit 390, which is my full plan. And there are some shifts where I actually make 378, and so on and so forth. So every shift you get the actual production. Now you also see some cells that say breakdown maintenance. So what happened there is that the hobbing machine had an unplanned breakdown. So unplanned breakdown can happen due to many reasons. It could be an electrical fault, which meant there was no power on that line, or it could be a jam in the machine, which meant the machine had to be completely taken down, and some of it had to be taken down and rebuilt, or it could be a flywheel which got broken. So there's a number of reasons for why breakdown maintenance happens. And when that maintenance happens, in a very simple way I've shown here is that the entire shift production is lost. So I wanted to make 400, but I didn't make anything. There's zero production. In the 3rd of October, first shift in the hobbing machine, there was a breakdown and there was no production. And you see the impact further down. If you see the same day on the second shift, the broaching, I plan to make 390, but I'm making 0 because there's no hard parts coming to my broaching area at all because of the breakdown maintenance. So you see how breakdown maintenance actually disrupts further in the production chain, right? Because of that sort of thing. So you see the actual quantities. Yeah.
So when you are doing maintenance, I understand, if there are 5 machines in the entire line, then each worker is doing maintenance on each of those machines, and that is understood. But if there is a breakdown, let's say one machine has broken down, then the other 4 are also idle because one has broken down, right? The other 4 can't continue doing their task.
Yes, if it's subsequent in the production process, right? So if the output of this machine is required for other machines to work, then they'll all have to be idle, right? That's why you don't want to have too much dependence on just one machine in the organization. But if you have 4 hobbing or 5 hobbing machines, right, in parallel, and one of them broke down, there's no problem because you can continue using the other 4 hobbing machines. Then there will be a ripple effect, right? Because the product is the semi-finished product or the work in progress is not available for further steps in the production operation.
Understood. The next, sorry, you were saying something.
I'm just going to conclude saying that the last row you see is the cumulative output, right? That means after broaching, that's when the gear is fully available, how much I'm able to make So that'll keep adding, right? Every day's production, every shift production will keep adding. And then you'll see at the end of the month how much I actually made for gear 6A, right? So the last thing will show you how much was made. And it's less than what I actually planned, right? So if you go all the way, you'll see that the cumulative output at the end of the month was 8690 units, right? So the last day of the month, after shift 2 was finished, I was able to make a total of 8690 gear 6A against a production schedule of 9,000. So if you go back to our previous table and see October 2019, how much I wanted to make for gear 6A, it was in the previous worksheet we saw, it was actually 9,000. But in reality, I could only make 8,690 units, right? So that is why we're trying to say that the actual production will differ from the planned production. And the closer you can get your actual production to the planned production, the more your overall efficiency is from a manufacturing perspective.
Is that the key question in this shape? I mean, that you want to see the effectiveness or efficiency or some metric, some measure of how good production planning is and execution is.
Yes, there is a very commonly used metric called overall equipment efficiency, and there is a very nice illustration that shows how that's calculated. So I wonder if you can draw up that particular picture.
Do you want me to bring up a picture, Shiv?
Yes, for the overall equipment efficiency. That will show how it's calculated. Yes, so this is the most commonly used metric to evaluate the manufacturing performance. Right? At the end of the day, there are world-class factories that do really, really well, and there are factories that are not that good, that don't do really well. And how do you differentiate how good is the manufacturing system? The most commonly used formula for that is overall equipment effectiveness. It's a gold standard for measuring productivity. And that actually depends on, it's a compound metric. It's based on 3 things, right? The first thing is the availability. So the availability is how much time was lost from the planned production hours. So we saw that the hobbing machine had a breakdown in one of the shifts in the month, right? So if your plan for the whole month was, I don't know, like 20 shifts, right? And one of those shifts was a breakdown. So that means that time is lost. So out of the 20 shifts, 8 hours each. So 160 hours was the planned production hours in this case. But the lost time is 8 hours, let's say. So you basically, the availability is the 160 minus 8 divided by 160, right? Which is basically 152 by 160, which then translates to 95%. So your availability for that month for the hobbing was 95%, right? So that's the first part of the OEE. So if you had the machine was fully available, there was no breakdown, there was no lost time, then your availability is 100%, which is the ideal scenario. So if your maintenance, you are given already a shift for maintenance in the beginning of the week, if that was done really well, you should not have lost time because your plan should be equal to your actual, and your availability will be 100%. But in reality, these things happen, so your availability will be less than 100%. The next part is performance of the machine, which means what's the actual machine speed divided by the design machine speed. So this means that in some operations, in some types of manufacturing, you want the machine to be able to produce a certain number of units per hour. But in reality, the machine may actually be running slower, or the people that are running the machine may not be most efficient. So your actual output is slower, or the production is slower than what you plan. So that affects performance. So that is the, if the design machine speed was 100 and the actual was only 90, the performance becomes 90%. And then finally, the quality, which I talked about as scrap, right? Which basically says, if I wanted to make 100 units of good product, but 5 of those actually turned out to be bad product because they didn't meet the specifications for quality or whatever, and they become scrap and they're thrown out, then I get only 95, right? So 95 by 100 then becomes quality percentage. So the quality percentage will be high when your input materials are of high quality, your process is very well defined and stable and doesn't create errors, then you get 100% quality. If some of these things are not there, then your quality will actually decrease, and some of the product you make you have to throw away, right? So that's quality. So OEE, overall equipment efficiency, is effectiveness is really the multiplication of all these 3 ratios. So if it's availability multiplied by performance multiplied by quality. So if your availability is very good, if your performance is very good and your quality is very good, then your OEE will be very good, right? In the industry, even very mature manufacturing companies are not achieve anywhere near 100% OEE because they would have some losses. So for example, if your availability was only 90%, your performance was only 90%, and your quality was only 90%, then you can imagine the OEE will quickly drop, right? Even though you're 90 on each, when you multiply all the 3 90s, now you are looking at 72, 73% OEE, right? Which is kind of what is the best in class. Many companies are at 40, 45, 50% OEE. So this is a very good metric.
45% OEE, huh? That's what it is.
Yeah, many companies in the industry, average companies will be 40 to 50% because they'll be 80% in each, right? For example, right? But when you multiply cumulatively, it becomes hard to achieve more than 50, 60%. So world-class companies are in the 70 to 80% range of OEE.
And the reason you've decomposed the OEE into these 3 things, availability, performance, and quality, is because the kind of control that you need for each of these is different. What you need to do to improve availability is one thing, what you need for performance something else, and for quality something else.
Absolutely, that's a really good point. The responsibilities within the manufacturing company are also somewhat different. So for example, the maintenance department is mostly evaluated on the availability. So if they are doing a really good preventive maintenance and so on, the availability will be very high. The human resources training, that affects performance. So if the people that are running the machine are not fully trained in it and they are not very skilled in it, it will slow down because somewhere somebody will not be able to meet the required speed with which they are doing some operations. So typically that affects performance. And then the supply side, right, the procurement department, etc. They have a lot to do with quality, but also the training and everything affects quality. But definitely, if you don't get good raw materials, your quality will suffer. So quality is, so these are all somewhat different. Like who's got more influence or impact on these three things?
Okay, should we go back to the Excel sheet?
Yes.
So we were done with that Excel sheet, no, Shiv?
Yes, that is an interesting Excel sheet. Some of the questions I'll have, for example, is what is the OEE, right, for the different machines, and does it change week to week? Is hobbing better or broaching better? In terms of OEE, right? So those are some of the questions to be analyzed.
Okay.
Another question that arises is there a difference between shifts? A lot of companies consider this deeply, right? Because sometimes, especially when they're running night shifts, performance, for example, may not be as high as in a day shift. So do you see any differences in the shifts in this case, right? It's also a good question to analyze.
Okay. Okay, Milind. So this okay, Milind. So this we now have to work on the production. The production scheduling is not much to do, but I think let us review what Shiv told us about that production scheduling thing and scrap what you wanted to calculate, right? Some scrap analysis, something.
Yes. So should we look at the data first?
Let's look at the data, and I mean there were a lot of new things for us right here in terms of some all these specific things which happen in production like changeover and maintenance and all that, right? Breakdown, some such thing. First, you have the calendar. Huh? Basically, you have every day of the month there is a amount to be produced.
Yes. So there are two calendars, GB. There is one calendar is for the hobbing, and the other is for the broaching workstation.
And this for each gear.
This is this is just for gear 6A.
It's all for 6A. It's all for 6A.
All of this is for gear 6A.
Gear 6A. So we are only working on one gear 6A.
Correct.
Gear 6A, okay. Gear assembly 6A, right? Because
gear assembly 6A. No, gear 6A.
Gear 6A.
So,
not assembly. Just a gear.
Yeah, gear assembly 6, and that is two gears, 6A and 6B.
So we are not worrying about assembly. We have 6. Okay, assembly has 6A and 6B. We're only doing 6A, and the 6A has two stages. It has to do, you have to do hobbing.
Correct.
Which is the outside, the teeth of the gear. And then broaching, which is inside of the gear, right?
Correct.
Something inside the gear so that it sticks to the shaft properly, right?
Yes. Yes.
So that's how I understood it. So you have to do, okay. So we have the hobbing workstation load schedule.
Yes.
And then we have the broaching workstation load schedule by day of the month.
By day of the month, yes.
Okay. Now we have to take the schedule and
given us more. They've given us more. They've given us.
Somebody has to take this and convert it into a schedule shift-wise, machine-wise shift-wise, presumably, right? So because then you know what to do with each machine, something like that. So they have a hobbing machine, and then you said on first shift you are going to use that first shift for changeover because some other gear was being made, so you have to change over to this gear. So all the configuration parameters have to be reset. So they tend to take some time, so they give the whole shift for it. They don't want to disturb. They don't want to do half a shift and all that. Doesn't make sense, I guess.
Yes.
So the whole shift goes for changeover and all that. And sometimes you use the free shift for doing maintenance work, like changing the oil, putting something else, removing all the gunk from the. I guess gear when you're making it produces all kinds of metal things lying around, and some of them may go and sit somewhere inside and all. So you do that. So maintenance. And sometimes also you have this crazy thing that happens, which is breakdown maintenance, unplanned, unscheduled maintenance. It breaks down, and so you have to repair it. Like electrical fault may be there, some tool bit may be broken or something like that, right?
Yes.
So then you have to do some maintenance. Again, you give it one shift. It is one shift.
Correct.
Okay, interesting. So then what we have done basically is that we have taken the shift and you have said either it is changeover, it is maintenance, it's breakdown something, or there's a quantity being produced.
Yes.
Okay. Now, on the top line you have quantity being okay. Your top line you have the quantity that was planned. No, yeah.
Yes.
Plan.
This table is the plan. The row number 33 is the plan.
And the 390 versus what? So you have 390, 400 comes out of hobbing in shift 1.
Yes.
And that goes to broaching in shift 2.
Right.
Right. If it is hobbing in shift 2, then it will go to broaching in shift 1 like that. So 400 items are produced by hobbing, and that goes to broaching. But in broaching, you see only 390 because 10 are assumed to have, when you're planning, you're assuming 10 of them have disappeared because of, what do you call it? Some defects.
Because of loss, basically.
Loss, basically. Some defect. Yes. Some defect. So you don't take all the 400, only some 10 are gone away. So 390 you get. So you're planning with 390 for broaching. That is the idea.
Yes. Yes.
Of course, it may not, the scrap may not be 2.5%, so it may end up being 395. You don't know.
Yes. Yes.
But you're planning with 390, something like that. But then the bottom thing shows the actual production in October, 1 month. 1 month actual production for gear 6. So what happened here is that instead of 400, you produce only 388 for whatever reason. I mean, it could be because it did not run correctly full time, or labor was a little lazy, or did not use one of the things which.
Yes.
So 388. So that means 388 will only have gone to broaching, not 388.
Yeah. 388 would have gone to broaching. Correct.
Maximum can be 388. Maximum.
Correct.
But some disappeared because of faults, defects again.
Correct.
And so in this case, what has happened is 11 is defective. All right.
Okay.
So what is the problem we have to solve now?
We have to now compute every day how much was the scrap.
Day or shift?
Every shift. Every shift.
Every shift.
Okay. Every shift. How much was the scrap? That's what we have to.
Do this crap. So it's subtraction. Huh? There's nothing to this.
It is subtraction. It's a little. There's a slight subtlety. Let's take a look at it.
Okay.
So GV, what we'll do is, I think the first thing we need to do is to just simply copy these rows, right? These first two rows, which are the titled rows. So we'll just do this equal to business as usual, and we should be. Okay. Now, a few things that have happened here is actually it may have been simpler to, because now the source formatting has gone. If you see, so it may have been simpler to just copy this entire two rows and paste them here. Let's do that. Okay, this is better. And then these two also will copy in the same way, and we'll call this scrap calculation. No scrap because this is. So obviously in shift 1 there is no scrap because this will be 0.
You don't have data for it.
Here also there is no scrap. Here we need to have scrap. So what did we say? We said very simply that it will be the output of broaching at the end of this shift minus the output of hobbing, or output of hobbing in the previous shift minus output of broaching in this shift. Right?
Correct. Yeah.
And 11, that makes sense, right?
Correct.
So we can just drag it, right? But now here you see a problem, GV. So here, if you see, the cell says that there was breakdown maintenance. And therefore, the value that is stored in this cell is actually not a number. So we are now trying to subtract 0 from something that is not a number.
What do you do?
And therefore, the result seems to be an error.
So leave it. So the problem is that later on you try to do some sum or something.
Correct.
So you can leave it now. What does it matter?
Well, because later on I have to do sum. So see, as an example, at the end of this week.
No, I understand. You may have to do some sum or some calculation you have to do.
You have to do the sum of all these numbers to see how much was the total scrap for this week.
That will give error.
Now I will not be able to do the sum because that number is not
value thing by 0 or something. I would
like 0. So the interesting thing is to see how to do this automatically. So what is it that we want? We want this difference. We want output of the previous shift minus output of broaching in this shift.
You want to check if the difference. You want to check if the difference is a number. If it's a number, then print it. If it's not a number, put 0. Is that right?
Yes. So we want to say that if it is an error, if in the subtraction you get an error, just make it.
That is another way of doing. Subtract it, see if it gives an error. If it's an exception, it's an error.
It is an exception. Yes.
What is that?
So
error.
There's a function called if error.
Okay.
So what if error says is, if there is an error, if the value is a value, that's what it is. So operations. So what it says is compute D39 minus E40. If the computation succeeds, return the value of D39 minus E40.
You write it again, no? Don't have to.
No. It's like an exception. It's exactly like an exception. If during the computation of D39 minus E40, the value that whole thing. And maintenance to holiday to holiday. I don't need to do anything special.
Nice.
The scrappage concept. Now you know that in week 2 you were going to only work on year 6B.
I see. So now no numbers. Okay.
So again you will see that scrappage.
Yeah.
Now when we do
number of those rejects.
Yes. Totally 128 items got scrapped.
Out of how many?
To do some totally how many were made. We can see here. That number also I can.
That is a cumulative. Huh? That is cumulative. Isn't it? I think
It is cumulative. That is cumulative. He has given us cumulative.
Oh, okay. So that monthly, cumulative monthly output. They track that, huh? Because I guess incentives.
If you want, what we can do, it may make sense. We can do this cumulative monthly scrap. Okay, so we can say this is this, and this is cumulative scrap so far plus scrap in this week in this shift. So this will be 11, then 18, and so on. Right?
If you double click that, it won't do the whole row.
Maybe. No, it does it for the column, not for the row.
It doesn't. Okay. Okay. Dil mange more.
So you can see cumulative scrap is 128.
Write it as a percentage also. That would be nice.
Yeah, we'll do that actually. That makes so production. Roughly 1.5%.
Can we try this? Can we plot the cumulative monthly scrap versus cumulative monthly production?
We can try.
We should just do a month. It doesn't.
No, there is no pattern.
It doesn't look like this. Okay. Scrap during the month of October, which is 2.5% is the amount allowed. We are doing 1.5%, so we are doing okay actually. Monthly October month.
We are doing okay.
Month of October.
Only other thing that is maybe worth paying attention, GV, is to figure out actually just in terms of raw material, what was the value of the raw material that we lost due to the scrappage?
How much of money got lost?
How much of money, right?
Huh?
Yes.
How much you lost because of scrap material? Only material.
Correct.
Of course, waste of labor, the waste of electricity and all.
Correct.
But we have no inputs to estimates. But we have material costs. We have material costs.
Yeah, the material cost.
Let's do it.
So here is what we know, right? We are going to produce gear assemblies, gear 6A, not gear assemblies, gear 6A. And if you look at this, it says gear 6A is made from blank 012.
Okay.
And blank 012 costs 35 rupees.
So we look up and all that. We'll do all that.
That may be a little too difficult, but we can just.
So just 35 rupees. Yeah. So just
multiplication. So material cost of scrap will be this into.
You should look up and all, but it's all right. Yeah.
We can do lookup. Generally, you can do one level of lookup, but two levels of nested lookups don't work. So then we would need to do some little bit of scratch work.
Anyway, this whole sheet is only for 6A, so it's all right.
Yeah.
Okay, 0 plus during scrappage.
Yes.
Generally, you have planned for budget. Your budget is 400 cut 2.5%, which is 10.
Okay.
Plus day, multiplied by 31 days. So 310. Multiplied by 35.
If you think about it, no, GV, your total lost budget will be 3. So if you do the same thing here, so if you do the cumulative, right? So
error, no?
Yeah, we'll have to do it.
Okay. You should do F33.
No.
Correct. No, it's correct. You're right.
3,900.
Yeah, it's correct. Useful thing. It's very useful. Planned production.
Oh, I should have summed up 400. You're right. Correct. I can do that also. Or maybe the students can do that as an exercise.
Yeah.
Right?
Yeah. So anyway, I think you get the drift. So basically, anyway, the planned number is much higher. It's like 8,000-10,000 rupees of wastage they were planned for, and they actually ended up doing wastage of about 5,000, half of it.
Yes.
Primarily, partly because you're not producing that much. That is one. Not good news. The other is that you're doing it 1.5% rather than 3%, 2.5%, which is good news.
Yeah.
Right?
Yes.
So for two reasons, it has come down. Total scrap. Okay. So monthly, every month you do, and then you see which months are doing well, which months are doing badly.
Yes.
He's also saying that some shifts you do well, some shifts you do badly, and all. But let's discuss what it means.
Correct.
So the next.
Yet here it does seem to happen that shift 2 is high, scrappage is higher than sorry. Here. So here it is cumulative.
You want to really do that analysis, you should do sum of all the scrap by shift.
That is correct.
Sum of the series with that first one being shift.
Yes.
And compare the two. That's what you should do.
Correct.
You can find out if it's less productive, which means count up or shift 2 is better than shift 1. Shift 1 is
equipment, overall equipment effectiveness, I think.
Overall equipment effectiveness. How well the equipment is doing overall. Okay, something like that. Now, so it's a product of 3 something. I mean, can you plug the slide?
Let's maybe it's a little complicated, the formula.
So this is what it has 3 factors. These are factors, right? 3 factors. So you're planned for some number of hours, you lost some hours. So you subtract the number of lost hours. So basically, you're trying to compute how many hours you lost or did not lose. How many hours you did not.
Look at the data. So we'll go back to this gear 6A data.
So changeover and maintenance are assumed to be planned, I guess, huh?
Yes, I would think so. Okay.
So the only thing that is unplanned is the breakdown maintenance. What is marked there under it? Otherwise, everything is planned.
Yes.
Correct, huh?
Correct.
Okay.
So if you look at this planned production hours minus lost time.
And since we don't have hours, we only have shifts. We can count shifts. Doesn't matter, right? So we can say number of shifts planned minus number of shifts lost.
One shift is 8 hours.
One shift is 8 hours, 12 hours. I don't know. Okay, 8 hours. 8 hours.
8 hours. Let's just say 8 hours.
But we don't. It doesn't matter. The 8 will get cancelled because numerator denominator.
Correct.
So we can just count number of shifts, right? So we can say number of shifts planned minus number of shifts lost divided by number of shifts planned. That will do the job.
Yes.
Okay.
Yes.
Then,
and the only thing you can lose is really this breakdown maintenance, I guess.
Okay, right? So you can say number of shifts planned minus number of shifts with breakdown maintenance divided by number of shifts planned. But when you're doing number of shifts planned,
No. So now I have an interesting question. Okay, so
I thought maybe I also have some question.
For hobby, we can say that we lost a shift because of breakdown maintenance.
Yeah.
For broaching, actually the machine was available in shift 2, but we produced 0.
Oh.
No?
Count it or not? Count it.
So, and we produced 0 because in the previous shift, hobbing we had not produced anything.
So that also we should say that it's lost shift, no? It's lost only.
So I suspect that they would not count this as a lost equipment hour. They will
count it as the next factor. Oh, I see. Let's go back to that PPT. I think that's what they will do. They will count it as a lost in production. What is it? Next one is performance.
Yes.
That will be 0 the denominator and denominator. That's what happened.
And my guess, okay, why they would do it like this? This is just my hypothesis. We should check with you. I think availability is the responsibility of the maintenance crew.
Yeah.
Performance is the responsibility of the people who are working on the shift. Right? So if the machine breaks down, then typically you would say that it has broken down because we didn't do preventive maintenance. Possibly.
Yeah. Yeah. I guess so. I agree. So again, now even for the availability, I have a question. Should we include just go back to that thing, that Excel minus number of breakdown shifts divided by number of shifts planned, isn't it?
Correct.
So when we say shifts planned, do you include changeover and maintenance in that shift plan, or we don't include that? We should not, no?
I think we don't.
We should not. Is my opinion. But we should check which.
Yeah,
I agree. We should not. So we should say number of shift plan, which basically does not include changeover maintenance, minus breakdown maintenance divided by number of shift plan. Okay. I think that first part is very clear. What is the second one? The performance. Performance is how much you produce divided by how much you plan, right?
Yes.
Okay. So 393 by for hobbing, 393 by 388 by 400 in shift 2.
388 by 400. Yes. Yeah. For that shift.
So
shift
actually, of 110.
We should look at it as the sum of
all. So let it be done for week 1, and then week 2 is gone anyway. Week 1 and 3, 2 weeks.
Yeah. Correct.
That tells you.
That will tell you performance.
And this you will do at the output of broaching, because we don't want to divide it. Correct, something like that.
Correct.
That will be performance. Okay.
Yes.
That's performance.
And the final one is quality.
Oh, so product.
So if you look at broaching, in theory, this machine can work on 400 units in one shift.
Yeah.
Okay. But because the input is only going to give it 390, in a shift, the maximum it can produce is whatever is the input that it got from the previous stage.
Right.
So even theoretically, the maximum machine speed that it can have in this shift is 390 divided by 400.
So 390 by 400 is the performance. And 383 divided by 390 is
the quality.
Oh, that's how one has to disaggregate. What we did earlier was a product of two things. We should disaggregate.
Correct.
390 by 400 is production, is the performance, and 383 by 390 is the quality. Understand? Okay.
Yes.
So I think we should leave it to
383 by 400.
Understand? Yeah. So let them do this. I think as an exercise, we should leave it. I think we should is the performance.
383 by 400.
Understand? Yeah. So let them do performance and quality. These one, and then do it again.
It's very difficult to reach 100%. Actually.
It's nearly impossible to get.
Seems very difficult.
You have
so many things can go wrong.
You should run it at full speed, and you should know defects. Impossible, not possible.
Yes.
Okay. So actually, if you have 90% availability, 90% performance, 90% quality, 0.9 into 0.9, 0.9 to 0.9 is 0.81 multiplied by 0.9 is some 0.72 or something.
0.7, yeah, 72%, 73% is what you will get.
That is assuming that each of them is running at 90%.
Correct.
You want to get it above 90% overall. You run each of them at 95, 98, 99% something.
Yes.
Okay. Quite tough.
Yes.
All right. Excellent. I think this is good.
Quality, I think, quality we may be able to drive at maybe 97.5% because she did mention that scrap was 2.5%, right? So, but I don't know if the rest of it we can drive at that.
Availability is 0-1, right? Either you have breakdown or you don't have breakdown. Breakdown 100%. If you have breakdown, one shift is gone. You have only 60 to 12 shifts in a week. One shift is gone means that is straight away 8%.
Yes.
Yeah. Availability is hit and go. Something. It's you don't know. You might get it or not. Performance, other than it, is a function of how well the guys are doing on that shift. Okay. I think this is good. Let them do this exercise. Right? Let them find out availability, performance, and quality for week 1 and week 3 for the data given. Okay.
Okay.
This data starts to speak about the actual costs and margins of the different products. This data starts to speak about the actual costs and margins of the different products. So we have seen that the company makes 10 different gear assemblies. We have shown a couple of them here, 3, 4, 5, and 6, right? And we know from the very first spreadsheet what's the sales price of these products, right? We looked at it for the 6-month period from October 2020 to March 2021. So each of these products sells at a certain price, but how do we know which products are making more money for the company? Which products are more profitable? where I should put more of my focus. Because it's one thing to sell a lot of products, right? But if the products are not getting you the profit, then that's not going to help the business. Whereas there could be some products which may not sell that many quantities, but are more profitable than others. So it's very important for us to understand as a business which products actually are bringing the margin, right, or the profit margin for the company. And what this table shows is how do you break down the standard cost and profitability of different products, right? So think of it as different cost components that a product is made of. So if we are making gear assembly number 3, there are different cost components that go into it. We know that gear assembly 3 requires gears 3A and 3B, and gears 3A requires a certain type of blank, and 3B requires a certain type of blank. So the direct materials are actually the cost of the material that's actually used in producing that particular gear. So that will be the sum of the cost of blank used for 3A plus the cost of the blank used for 3B forms a direct material cost of that gear. So direct materials are the cost of the materials that are directly attributable through the bill of materials to the particular finished product. The next part.
The reason this is left blank is, I guess, we are expected to find it from the cost of the blanks. It can be determined from something else, so that's why it's not written.
Other spreadsheets that will give you what is the cost of different blanks. So we want you to figure out what is the cost of the direct material for gear assembly 3. By following the bill of material, you'll be able to trace and find that out. Direct labor is another cost component, which is basically the people that are involved in actually making that particular product in those lines, the hobbing line, the broaching line, the assembly line that's used for that particular gear assembly, that's direct labor. So all of the salaries, the benefits, the overtime, etc., that's paid to the employees or the contractors or the staff that make those products goes into direct labor. And the third is production overhead. So,
and even that direct labor, we can compute it from something else that is available, or?
No, I think that should be provided. I think that might have been a miss, so that might be, yeah, it is there in this next spreadsheet.
Okay.
The third one is production overhead. So if you look in the factory, you can see that some of the components you can directly cost it, it's the direct material. And some people, are working on the lines that are specifically used for making gear assembly 3. But you'll find a lot of the cost in the factory cannot be directly connected to one product. For example, all the maintenance crew, all the lighting and electricity that is used to run the factory overall, right? The overhead lighting, which eliminate all the entire factory, the air conditioning if it's required. The production supervisors who may actually supervise multiple lines, the factory manager's salary, all of these things are what form production overhead. There could also be indirect materials. So the materials that we use to lubricate all the machines that we buy, right? Lubricants that are used, or it could also be other types of materials that we use in a common way, like for example, if we actually buy water to run the factory, right? Or if we buy a certain cleaning agent to clean the factory. So all those things form production overheads. So those are all the costs that are occurring in the factory, but cannot be directly connected to one product. We collect all those costs together, and then we apportion that. Apportion means divide it in some way so that it is allocated to all the different products. So that's called production overhead. So here you can see the amount of production overhead that we've decided to attribute or apportion to each of the products. And there are different ways in which that apportionment is done. There is activity-based costing is one way in which you can create a better apportionment of the overhead to the different products and so on. And then there's finally general and administrative overhead. So these are all costs that occur outside the factory. Your sales team, your distribution team, their costs, your management team, like the senior management of the company, their costs, the head office, which may be outside the factory, maybe in the city, the cost of operating that head office. All of those costs are again collected into general administrative, and it's also distributed to the different products that the company makes. All of these costs together will give you the cost of the product. If you go back to the previous tab, it will show you that the cost of goods sold is actually the sum of the 3 that we just discussed, right? The direct material, the direct labor, and the production overhead. That forms the cost of goods sold. And then the margin, if you go to the right of the spreadsheet, is actually the gross. It's called the gross margin. The gross margin is the average sales price minus the cost of goods sold. So that gives you the gross margin of each product. So I think in this exercise, you can figure out what's the direct material cost. The next tab gives you the other component, direct labor and production overhead. And then with that, you can calculate the cost of goods sold and the margins. And the question I would have is which product has the highest margin, which product has the lowest margin, and how do you make decisions about how to prioritize? If you have a constraint in the capacity of the overall factory and I want to prioritize the products I'm making, then the question would be which product should I prioritize first to make, right? So those are some of the questions involving the margins. So this is the final stage of the whole chain, right? So we talked about how much of the finished products we are selling. Then we talked about how much of the finished product we should make every month in the 24 months. Then we talked about how much of the semi-finished product we should make, which is the gear 3A, 3B, or whatever, right? 6A, 6B. Then we talked about going down to 1 month and figuring out shift by shift how much I should make of in each machine, right, of each product. Now we're coming back to a higher level view and saying, we know that to make a certain gear, we need gear assembly, we need gears and we need blanks, right? We need different types of blanks. In reality, we actually need 6 types of blanks. With these 6 blanks, we can make any gear, if you see the bill of material. And with those, we can then make any assembly, right? But at the end of the day, it comes down to buying 6 blanks, right? 001, 002, 011, 012, and 021, 022. Now, as a purchasing department, I am entrusted or I'm asked to make sure that I buy the right quantities of these 6 blanks so that my gear production can happen smoothly without any disruption. There should not be any lack of blanks that is preventing me from carrying out my production schedule of the different gears that I want to make in my production process, right? Now, what we find is that if you trace the whole bill of materials down, you'll be able to see the actual amount of each blank that is consumed in each month from April 2019 to March 2021. So you see column number D, and if you see D4, the cell, it says production issues blank 001 is 6270. What that means is that during that month of April 2019, I had to use 6,270 units of blank 001 because I'm making some gears. There are a number of gears that require this particular blank. So my production schedule is asking me to make sure that 6,270 blank 001s are available to be issued in that month into production. Issued means given to the shop floor, right? So from the raw material store, I have to give that much quantity to the shop floor. Now, when we talk about purchasing, it is about placing orders to make sure that in time I get deliveries of my materials into that can then be used for production. So what you see here is something called order quantity. And order quantity means how many orders, how many units should I order with my supplier in a certain month so that I will get that order quantity in the following month, right? So what you see here in this table is that in March 2019, I had an ending inventory of blank 001 of 11,230 units. So that's how much I had in the store, raw material store. And I again placed an order for 7,698 units. Now, in all this entire sheet, the assumption is the lead time is 1 month. So that means if I place an order for 7,698 units in March, I will get it in April. So the following month, I will be getting the product delivered from my supplier into my factory. Now, this sheet shows you the amount of production and the amount of blanks that I need to issue every single month for the 24 months. And this then will give us an interesting puzzle, which is how much should I order in each month and how much will be my ending inventory of each month in these 24 months. So this is the exercise that we'll have to do. Now, to make sure that we order the right quantity, there are certain formulae that we use. So if you come back to the slide presentation, you'll see that there is a concept. There's a couple of concepts in module 9 that I want to give an overview. So if you see here, sure. This shows the concept of ABC. So that means of all the products all the materials that we buy in a particular manufacturing company, there could be some materials that are called A category, which are the highest value, right? They are actually forming maybe 70% of value of everything I buy. But in terms of numbers, they're usually very small. Few products contribute to a high value of the overall pie. So those are called category A materials. We want to tightly control our inventory. We want the maintenance of the records to be very accurate. And usually we use the planned order concept to release orders just in time for those products. Then you have medium, which is category B, and then category C, which is low in value but high in number. There's not a lot of little things like nuts and bolts and things that form category C, where we may not want very tight controls, and we may use methods like economic order quantity. Now, here we are going to use this concept of safety stock and lead time demand to order the blanks, because the blanks are definitely valuable. And we need to make sure that the ordering, we don't over order, which means we end up with too many blanks and stuck money and stuck capital. And we don't under order, because we under order, that means that we will not have enough blanks to actually make the gears that we want to make. So the concept here is that gear blanks are considered as a B category, and we want to use this concept of safety stock in here. So the graph that you see on the right side shows the inventory level. So how many blanks do I have in my store? That's what that graph shows, right? So at time 0, we start with a quantity Q, but every single day, as I keep doing hobbing and broaching, right, I keep taking some of these blanks for that process, and the amount of inventory we have keeps going down, right? When it crosses that line called reorder point, that means it has gone below a certain level called reorder point. Immediately, I want to place an order with my supplier, and the quantity amount that I want to order is called the reorder quantity, and the level at which this order is placed is called the reorder point. Now, what happens is that beyond the reorder point, we keep consuming more and more and more, right? But before we reach 0, right? Actually, this graph is not quite showing. There's a point just above 0 that we actually receive the order that we just placed, right? When we cross the order point, we place an order, we receive those products in. So the inventory then goes back up to a high level, and then we start consuming again. Again, when we cross the order point, we place the next order, and then we receive the next order, and so on. The idea is that the lowest point you ever want to go is not, you never go negative, right? So you should not have negative inventory, which means that you never have to stop production on account of not having the product on hand. So that's how this whole formula works. So there's two concepts to this. One concept is called safety stock, which means that we know there is going to be some variation in demand, right? Month and month and month, month over month over month. It's not the same amount of gear blanks that we're going to consume. So we want to make sure that we have some stock in hand that will allow us to tide between the maximum usage and the average usage. So we want to plan for a max average usage, but even if we hit the maximum usage, we still should not go out of stock. So that's the first concept, is a safety stock. The second concept is that after you place the order, there will be some amount of time called lead time until you get those products from the supplier. So during that lead time, you still have some demand that you want to cater. That's called the lead time demand. So in that picture, what you see between the order placed and order received, how much consumption is happening, that's the lead time demand. And the reorder quantity is the sum of the safety stock and the lead time demand. So that's the formula for how much is the reorder point. So the reorder point, yeah.
So Shiv, when we were discussing the e-commerce case, we have discussed this concept called stockout.
Mm-hmm.
And this seems to be very similar to a stockout, right? You essentially don't want to be in a situation where you are going to lose something because your warehouse did not have certain items.
Absolutely.
But here, what is interesting to me is now there is a fair amount of analysis that people are doing in order to avoid stockouts. So this is something new that we have learned in this session.
Yes, absolutely, Milan. So that's a very similar thing. So in an e-commerce setting, if you had a stock out, then you lose the sale, right? Basically, the customer doesn't get the product, or they go to another portal or another company. In this case, if you don't have stock, you lose production. The hobbing machine will be sitting idle. You have a plan to make 400 units, but you can't even start the operation because there's no blanks available. So losing production is just as bad as losing sales. So that's the reason why we want to avoid stockouts in this case. But in this industry, in this example, there's a very specific formula that's being used to make sure that we balance the loss from having a stockout with the loss from having too much products in our inventory, right? So this formula gives us the right balance between having just enough, order so many products at the right time so that you avoid stockout, yet you don't maintain overly too much inventory and lock up your money in that, right? So that's what this formula tries to do.
Sure.
Yeah, the EOQ is a concept that's used for the C category items, where we want to make sure that especially these are items where you consume a lot of space, right? So the holding cost is also an important thing to consider. Not only the capital or the money that's locked up, but also the warehouse, capacity, and all that. And this is typically used in the items that are physically take very large amount of storage, like packing materials, for example, is used using EOQ, economic order quantity, where you're trying to balance the ordering cost, because every time you place an order, there is some administrative cost to placing the order, and then the holding cost. So we will not be using this formula for our case study. We'll be using the previous one, which is basically the safety stock and reorder point and reorder quantity concept, right? So then we can possibly go back to the worksheet where.
Yeah, so, but in the e-commerce case, Milan, we saw that certain items like FMCG we were buying in cartons, boxes.
Correct.
So that is the EOQ. That's where the EOQ concept comes.
Absolutely. Right? So there was mobile and FMCG.
Mobile lifestyle and FMCG.
Correct. And I think that maps somewhat to the three categories that Shiv was talking about.
Right. Correct. Mobile would be category A. Lifestyle might be category B, and FMCG would be category C, right?
Yes.
Yes, absolutely. So this worksheet doesn't have the order quantities for each month, but there is, I think, maybe another worksheet that has. But what we are trying to do is use the concept of safety stock and reorder point and reorder quantity to make sure that we issue the right number of purchase orders for the right quantity in the right month. So that's what the exercise is all about. So possibly, when you actually get into that data, that can be explained. So I think at the high level, this is probably sufficient to show the purchasing side of the house. So the goal of the purchasing manager then is therefore to make sure that the right amount of goods are bought at the right time, to balance between the risk of not having stock, right, and therefore impacting production, versus the cost of holding too much inventory. So it's about how do you drive the right balance, and that's what the purchasing side is looking at. So the questions here would be possibly, what's the kind of variation that you see in the purchasing quantities between the different months? What is the right safety stock? What is the right reorder point for some of these products based on the data that's been given for the 24 months?
So, we need to get